So I will be talking for some CH functionalization reaction. As you know that in organic chemistry, various people are doing some synthesizing some medicinal important compounds, some synthetic chemistries. But recent trend is of a CH functionalization chemistry. How the concept has come, because earlier the reaction was a simple condensation reaction. The reactions were more highlighted with a invention or with the Nobel Prize of a Suzuki, Buchwald, and uh, Heck reactions. So just next slide, please. These are the reactions which were previously known for a cross-coupling reactions. Based on this one, just next, please. Heck reaction. I always remember Heck reaction is the basic reaction because in 1972, Heck is the first scientist who was working on some in a Becker's laboratory for this. He used palladium as a catalyst, and he has converted acetaldehyde synthesis. So mechanism for this reaction is like this only. Okay, see, I'm just telling the basic reaction. Okay, all reactions are going through a palladium reaction. How the reactions are changing? The reactions is taking place by PD0 is there. First step is oxidative addition, then transpetylation, reductive elimination, and final get the products. It is a concept of a concept of a medicinal chemistry, or sorry, it is a concept of a green chemistry approach or environmental benign reactions. So in this common reaction is what? So go back. This one 0 is there. Oxidative addition states changes to 2. Then it is going for coordination chemistry of this one, and finally beta elimination reactions, and you get the final product. Again, PD, what are the catalysts you are taking? You are getting the 0 catalyst again state by changing the status from 0 to 2 and back to 0. Next, please. Based on this one, Suzuki reaction, it is a very well-known reaction. I'm not going to discuss these things, why boron is taken, because boronic acid, everybody knows this one, and it's going for cross-coupling reactions and finally get the product. This was, I have published some of the work on this next Suzuki reaction. My first paper I published in a European Journal of Medicinal Chemistry in 2014, where I was working some medicinal important compounds. I thought that let me materialize this one, carbon-carbon coupling reactions, and let us see we carried out the biological activities. We got a very promising results, and my paper has published in this one, European Journal of Medicinal Chemistry. Next, please. Next is a Buchwald-Hartwig reaction. Common reactions, we are knowing this is an conversion, addition of a nucleophilic reaction of a amines to a sp2 hybridization. It is very common. People are going for addition elimination reaction, elimination addition reaction, but Buchwald is such a reaction through which we can go for introduction of a weak nucleophiles in a sp2 hybrid orbitals, sp2 molecules. So based on this one, next please. This is the common mechanism. Mechanism is, say, for all reactions. Mechanism, what I told earlier, it is going for oxidative addition, transpetylation, reductive elimination. It is a very, very common. But because Buchwald, only one difference is there, major difference you find, that is reaction is proceeded through a strong base. And based on this one, I entered, next please, weak nucleophile, because simple coumarin, 1,4-hydroxycoumarin was taken. It was converted to corresponding tosyls and mesylates, and we entered a weak nucleophiles. And the paper has first I submitted paper in Royal Society of Chemistry. I got a very good comment in Royal Society of Chemistry, and we entered successfully to the weak nucleophiles to the aromatic species. This reactions was carried out in some coumarin derivatives and some asparaginine molecules. My two paper has consequently came in RSCs as a 1 year at a gap of about 3 or 4 months only. Next, please. Sonogashira reaction. It is a very good concept of organic chemistry where sp3 and sp hybrid can combine to get a one molecule, complex molecule, not complex, it is one molecule. This is a simple Sonogashira reaction, halides and alkynes to get this molecule. Next, please. The mechanism is also here. Its mechanism is very common. Only a simple this cross coupling reaction has how these reactions are carried out, because in this reaction copper is used. Copper changes oxidation state from copper cuprous to cupric, and finally you are getting the products. How transpetylation is going through, coordination chemistry is coming, and this is its mechanisms. By this way, we can enter a sp hybrid orbitals, acetylene compounds to a sp2 compounds. That is in arene nucleus. Example is this one. Go for next. By this way, one of my dissertation student of a MSc, we have a MSc dissertation. One of my students was doing some reactions of because 4-chloro 4,7-dichlorophenolene. They have been synthesizing as a course of work. What I did, okay, 4 position was substituted with a simple nucleophile, and 7 position we just tried for sonogosy reaction by cross coupling reactions, and these reactions we have performed without copper, and by through palladium this we have reaction successfully. We have synthesized this compound. It was characterized, and the paper is accepted. It is one some revision has come, but this paper has come in a very good reputed journal. Next please. That is its mechanism. Operating is this one. We started palladium 2, then it has gone to palladium 4, and again palladium 2. So the system is there through which we can go for 0, 2, again 0, or we again back to palladium 2. Next please. So now based on these reactions, I am thinking to go for a CH functionalization reactions, because earlier trend, when such reactions was not invented, there was some halogens were required. Right now, if you don't have halogens, still you can functionalize this type of reactions. Only H can be functionalized. Earlier, what was the belief? If you want to remove a halide, so it should have withdrawing group ortho and para position, but that is not required. Any species can be eliminated, and any species can be added to an organic species. So these are some of the disadvantages. Okay, both coupling partners must be pre-activated. Organometallic compounds are required. These were required. This is pseudohalides are required. These are some disadvantages. But we can go for without halogens. We can synthesize by means of the other reactions. That is CH functionalization reaction. Go for next. So in this reaction, what is CH bond? A CH bond is converted into corresponding carbon-carbon bond. That is known as a functionalization reaction. I don't read it because of the time constraints. I don't read it more things. But this is the reactions where carbon-carbon bond is generated. Next, please. See, this is what is the basic differences in a mechanistic pathway between cross-coupling reaction and CH functionalization. Cross-coupling is going by 0, oxidative addition, transpetylation 0. Activation reaction is what? Okay, this is a PD2 is there. It is going for 2. There is going this one PD2 only. Transpetylation PD0. And it is going for further reoxidation. Just see this reaction. I am just giving for one example for a beautiful reactions we have done, and we got the successful products on this reaction. Let's go for next please. Yes, like this. H is there. What was the earlier belief? If you want to remove H from a benzene, it was very difficult. But right now, this by means of this organometallic compound or by means of the functionalization reaction, this reaction is very easy. So like this is H is there. Again, it is a concept of a hack reaction. It's going olefin. You like this reaction. Common mechanism is this one. So what is this? You just remove the bond from here. There. So next, please. Next, please. Yes, see this my work. It's a beautiful reaction. What is here? This is this thiazolidinone, very common compound. This nucleus is present in all antibiotics, particularly for penicillin. Very common organic preliminary people, they are synthesizing thiazolidinone by means of skip base and thiazolidinone. And if one of the H is left, this H, people are going for condensing with a aldehyde to get sterilities. But we have gone through other reactions. We have applied this species to some sterile derivatives to reverse hack reaction. Means this is H is there. Simple acetyl molecule is condensed to get this molecule. What the mechanism is proposed like this. See this point. Very interesting point is one. Okay, this is H is there. HX is eliminated. PDX is there. Now positive metal is joined. Again, it is going by olefinic compound to get this compound. It is going through a beta hydride elimination, and we got this double bond. Next step is what? Reductive elimination, PD0. And this species is again reoxidized by cupric 2, Cu2 to Cu1, and we got a PDX2 molecule, PD2 species. This is the mechanism. This paper has also come in a one molecular diversity. A paper has is accepted. So this is reaction. Alkylation reactions are there. Okay. Alkylation reaction. It is how many times? Oh, so how much is? Alkylation reactions. Go for next, please. Next. Go for next. 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 Yes. In this reaction, this is a reaction where sp3 hybridization is there, acetylene is there, and we have prepared these molecules. See, looking to these molecules, because why I am confining this molecule, because these all reactions are reactions are already developed reactions, but how we are applying to our basic moieties, because now research is done with what type of molecules, either chemistry should be new and old molecule, or new molecules and old chemistry. This is the way man can go for research. So this old molecule, and I have just condensed with acetylene, and we got this acetylene derivatives, CH triple bond C compounds. Next, please. Next. This is the plausible mechanism for this. Because of the time constraints, sir, if you give me 5 minutes more, I can just discuss something. Yes, I understand this point. Next, please. Carbon. Next, go for some. Go for no. Last is some. Yes, some of these. This is again amine compound is there. CH amine. See, people feel it something. CH-NH compound is very difficult reactions, but by means of this reaction, we can go for CH-NH reactions. It does not require any halogens, or it does not require anything. So we got these molecules, that is sp3cn coupling reaction. This also paper is accepted in a Wiley International European Journal of Organic Chemistry Journal. Next, it is a mechanism, proposed mechanism in this one. These are the mechanism for this reaction. Reactions can be operated by two ways, both ways. One oxidation and A and B, both pathways are given, and this is reaction is going by this ways. Next, please. Next, go for one slide, please. Next, go. I have prepared some more slide because yes. Now this is a carbene insertion reactions. So diazomethane people were telling that it is a very good reagent for methylation reactions because nitrogen is a very good leaving groups. So by means of these concepts, this one nitrogen is this carbene is prepared. Carbene is there, and a carbene is go for next. Carbene is inserted. Carbene can be generated by various means, by Bomford-Stephen reactions, by Shapiro reactions. But we have prepared next please. Yes, these are Shapiro reactions. I am not going to discuss this. Next. Yes, this one. Okay, this is what tosyl group is there. Tosyl hydrazone, very simple. I did sample acetophenone, tosyl hydrazone, and I condense it. This molecule is generated. And then next is mechanism. Mechanism is this one. Okay, see, this is reaction is going by migratory insertion reactions, and we were able to put a double bond there. These are why I am telling these reactions. Still, numbers of applications are there because of time constraints. I am not able to do this one. But these analogs of the carbene reactions are some nitrogen insertion reactions. Nitrogen also people are going by very simple reactions. Very new molecules or new heterocycles, new medicinally important compounds can be synthesized. Same applications are there, and you will be surprised to know. Suppose if you want to go for amide groups or acetaldehyde groups, by means of this nitride and cyanide insertion reaction, you can introduce with amide amido groups also by the same type of the analogs. So, sorry for this one, but I am more interested for this section. I kept my presentation, I loaded here. Anybody interested, you can take it in your pen drive, you can study it, and you can mail me it. I will be very happy to discuss. We'll have good collaboration, good conversation for these reactions. I have prepared about some 70 slides, but because I was thinking for about timing, but time is not permitting. So please, if anybody is interested, please keep it and converse with me. Thank you very much for patient hearing.